All right, well, welcome back. Today we're going to look at a problem like this where we have a trigonometric function over a restricted domain, and we want to try and find all the zeros. In other words, all the values of x that we could plug in that would make the output be a zero. And so we wonder, well, how many zeros are we looking for, and roughly where are they? So a good way to start this would be to kind of get a graph. And so on Desmos, I've gone ahead and typed in the equation 4 minus 7 sine. You can read the rest of it. And I didn't restrict the domain, though. I guess I could restrict the domain if I put in, let's see, a little parenthesis, -5 to 10, -5. Let's see here if I can remember how to do this. That's equal to x less than or equal to 10. Okay, and so there's the restricted domain. And I'm interested in the zeros. And so let's see. With Desmos, it's pretty easy. You can actually kind of click on the zeros. And so here we see the zeros. -2.26. Positive 8, 2, 2, 6, 5, 7, 7, 4, and 2. So it appears there are 4 zeros kind of within the domain from -5 to 10. So we're now going to see if we can find these things algebraically. So I'm just going to set this aside for right now, and we'll check our work at the end with this graph. So let's get into the algebra. How do we solve this? Well, as we've done in the past, the first thing is we're going to set the function equal to 0. So I'll do that first for sine pi over 4 x minus 3. And so now I'm going to try to solve this thing for x. So what I'll do first is I'll move the 4 over, and so that would be a -4 equals a -7 sine pi over 4. And depending upon your comfort level with the algebra, you might be able to do 2 steps in one. I'll just do things one at a time. So if you want to fast forward the video from time to time, feel free. So I divide by -7. So now I have 4/7 equals sine pi over 4 x minus 3. Okay, so now I need to undo the sine. So I have to do the inverse sine. And I know there are many angles that would give a sine ratio of 4 to 7. So let's put that right there. And let's see what our calculator says when we do the inverse sine of 4 over 7. I know there are many answers to this, but the calculator is only going to give me one value. So let's see. So let's make sure I'm in radian mode first of all. Mode, I'm in radians. That's good. And so then I'll go inverse sine of 4 divided by 7. And so I get about 0.6082. I'll just call it about 0.608 radians. Okay, so according to my calculator, I get about 0.608 radians. And at this stage is where you really want to be careful and be thoughtful before we just kind of race ahead with our algebra. Let's think about what this means. This is the step where if you mess this step up, you're not going to find all 4 answers, let alone 4 correct answers. So we have to go back and think a bit about what's just taken place right here. So I'm going to kind of make a circle. It doesn't have to be this large, but just so you can kind of see it on the screen. I'm going to think about a circle with a 4 to 7 sine ratio. This is a good exercise because it helps you make sense of the 6.08, and it's also going to help you figure out the other possible solutions. So according to this calculation, if I were to rotate 0.608, now remember 1 radian is a little less than 60 degrees, so about 60 degrees. So So that'd be about 1 radian. So 0.608 radians would probably take me about right about here-ish would be my estimate. That would be about 0.608 radians of rotation. And this should give me a 4:7 sine ratio. And I want to see if that looks pretty good. Does this appear to be about a 4? And this would be about a 7. And then in terms of size, yeah, that looks like it might be a 4:7 ratio. So I'm pretty happy with that 608 radians, and I see the 4:7 ratio. But now I want to be aware of the fact that, okay, well, 608, that's 1 rotation. That's the one the calculator gives me, the principal inverse sine. I know that there's another location on the circle where I can get a height of 4 and a radius of 7. And that would be if I went straight across to the left side over here. I have another 4:7 ratio. Height is 4 and the radius is 7. So this is also a sine ratio of 4:7. And I have to figure out, well, what kind of a rotation could get me over to that spot right there. So we're trying to figure out what kind of rotation, how many radians of rotation could get us right into that position right there. Well, many ways to do it. I find the simplest way is to say, well, I know from here to here is pi, 3.14 radians of rotation. So if I were to go 3.14 and then take away 0.608, that would give me a pretty good idea of what this rotation is. So if I were to take pi, so let's see, second pi minus 0.608 radians, I get about 534. I'll call it 2.534. So 2.534. So there are actually 2 rotations, 0.608 or 2.534, that have sine ratios of 4:7. And I need to think about both of those cases. So from here I kind of have to think about 2 cases. The first case, which is, okay, let's let inverse sine be 0.608, and let's see what that does. So that's going to be one case. So let's go ahead and see what this case tells us. So if I basically multiply by 4 and divide by pi, so if I were to say 0.608, multiply that by 4, and then divide that by pi, gives me about 0.774. So if I multiply by 4 and divide by pi, I get about 0.774 equal to x minus 3. And then if I add 3, I get 3.774 equal to x. And so I'm realizing that I may have a problem because I don't recall that being one of the zeros. So let's see. Okay, it's not, and I'm going, okay, there's a problem here. I see the 774, but it's a 5. And it just dawns on me, oh, there it is. My mistake was I typed in the wrong equation. So that's an easy fix. I'll make it a minus 3. Okay, so now I have the right equation. And so let me now check the zeros. I'm hoping I can see, there it is. 3.774, okay, is one of the zeros. So, okay, dodged a bullet there. I didn't realize I had typed in the wrong equation. But I'm happy with that 3774 answer. So, okay, so we're back in the game. We're doing okay. So this is definitely one of the 4 zeros that I'm looking for. Now you're going, okay, well, where might I find the other one? Well, let's think about the other case. We've already considered 608. Let's consider if it was 2.534. 2.534 equal to pi over 4 x minus 3. And let's see where that leads us. So again, I'll multiply by 4 and divide by pi. So 2.534, I say times 4, and then divide that by pi, about 3.226. 3.226. 3.226 equal to x minus 3, and then add the 3, so I end up with 6.226 equal to x. And let's see if that one is supported by the graph. So if I go back and open my graph up, 6.226. So I've got the answer here at 6.226. I've got the 3.774 number, but I don't have this one and this one yet. So here are the two that I've kind of found algebraically, 6.226 and 3.774. And we now have to find out these other two answers right here. Well, there are two ways we could go. One way, and I don't really recommend this, is you could throw on another revolution and say, well, let's add 2 pi to 6.08. So 0.608 plus a full revolution, which would be 2 pi. I could think of this as 6.891. This position here is 6.891. So I go 6.28 radians and then go a little more, and I can think about a rotation of 6.891. Maybe that, if I use that, will take me to a fourth answer. Or maybe instead of rotating this way, maybe I should rotate clockwise. I should go back 2 pi. And so I could take that 0.608, and let's go back 2 pi. And maybe we should be thinking about this as like negative 5.675 radians of rotation. And the point is, there's an infinite number of possibilities here. And so you might drive yourself a bit crazy trying to figure out, well, which one should I use? So again, if you want to go down that path, you can. It's not the easiest way. The easier way to do this, and this came up in our class the other day, is to remember that these are periodic patterns. These things have a cycle or a period. In this case, the period, let's see, if I wanted to go from here to here, well, that suggests a period of 8 units. I go through a full cycle in 8 units, 8-unit period. In fact, you could do 2 pi divided by pi over 4, and you could figure out, oh, the period of this is 8. It pretty much repeats itself every 8 units. So with that in mind, I could say, well, okay, I just need to take these 2 points here, and I need to go back 8 units and think about where they would be. So let me kind of close that. So one way is to say, well, let's go back 8 units from 3.774. So 3.774, let's go back 8 units, about negative 4.226. So negative 4.226, I believe that could be a 0 for the function. And then if I were to go from 6.226 and go back 8. That would be 6.226. Let's go back 8 units. Negative 1.774. Negative 1.774. And let's check these in just a moment with Desmos. And let's see if these work or not. Okay, so I've got negative 1.774 and negative 4.226. So there it is. We've identified all 4 zeros. So it's kind of using a combination of what we know about graphs and the periodic nature of these trig graphs, and thinking about on a circle, what's that second rotation. So it's you're going through algebraic process, but you're also bringing in some sort of visual help along the way. Again, the thinking about the circle and rotation, and also kind of taking a look at a graph and thinking about the periodic nature of the function. So this is the nature of kind of solving trigonometric equations. It's not a purely algebraic exercise. It kind of combines sort of algebraic and sort of visual and geometric aspects. So you're really having to kind of integrate the different types of mathematics that you have in here. So so there we have the four solutions. So hopefully this gives you some assistance on the upcoming assignment. Thanks for watching.